video, we're going to learn, not learn, actually write the algorithm for this array problem. All right, let's begin by reading out the problem first. So, write a program to declare a square matrix A of order m cross n, meaning that A will be a square matrix, has been said before, where m must be greater than 3 and less than 10. Before I move on to read the other part, you must ensure that m lies between 3 and is greater than 3 and is less than 10. You must ensure this. This is the reason why you need to keep a check in your program, which we will implement in our algorithm. Moving on. Allow the user to input positive integers into this matrix. Perform the following task on the matrix. Now, allow the user to input positive integers into this matrix. You don't need to check whether the inputs are positive or not. Assume that the user will give positive numbers to you. Okay. The first subpart. Sort the non-boundary elements in ascending order using any standard sorting technique and rearrange them in the matrix. Now, what is actually meant by this is displayed or demonstrated clearly from example 1. So, in example 1, the non-boundary elements are these: 13, 8, 6, and 3. Now, if you notice the same elements in the rearranged matrix, we'll notice that they are arranged in ascending order. First comes 3, then 6, then 8, then 13. So they are arranged row-wise. All right. Moreover, we need to calculate the sum of both diagonals. So the diagonals, I cannot create anything but a square box. So the diagonals are 9, 13, 3, and 8. And another diagonal, that's the left diagonal, and the right diagonal is 5, 6, and 7. So we need to calculate the sum of these diagonals. All right. Okay. And lastly, we need to display the original matrix, the rearranged matrix, and the diagonal elements. The sum of the diagonal elements we have to display. Okay. Those are the sum of the two diagonals. Display the original matrix and the diagonal elements. Okay. Both the diagonals. Okay. All right. So let's first understand how the non-boundary, what the non-boundary elements are, from which indexes they start, and then we'll move on to writing the algorithm. All right. Okay. So here I have two matrices in front of you. The first matrix is of order 5 cross 5, and the second matrix is of order 4 cross 4. Now, to find the non-boundary elements, what we do is we get rid of the first and the last row, first and the last column. So we get rid of the first row, the last row, the first column, and the last column. What remains is our non-boundary elements, are our non-boundary elements. All right. So tell me one thing. The dimension of the original matrix is 5 cross 5. But what is the dimension of the non-boundary element matrix? Meaning this part. Let me use a different color. Let's use this. So what is the dimension of the non-boundary matrix? So if you see carefully, the non-boundary dimension is 3 cross 3. Now let's do this. Let's do the same thing for this matrix as well. So to identify the non-boundary elements, we first get rid of the first row and the last row, and the first column and the last column. Whatever elements we are left with forms the non-boundary element. So what is the dimension of the non-boundary element matrix? That's 2 cross 2, right? Now, do you see a relation between M and the dimension of the non-boundary element matrix? So when the initial matrix has a dimension of 5 cross 5, the dimension of the non-boundary element matrix was 3 cross 3. When the dimension of the original matrix was 4 cross 4, the dimension of the non-boundary element was 2 cross 2. See a relation? Isn't it? This minus 2. If you thought of that, you are right. So in general, we need to find out what in general the dimension of the non-boundary element matrix is. So for a matrix of size M, the dimension of the non-boundary element matrix is M minus 2 cross m minus 2. Now why m minus 2? Think again. The 5 cross 5 was the size of this, or was the order of this matrix, whereas the size was 5 and m denoted the size. Same here. Therefore, the dimension of the non-boundary elements is m minus 2 cross m minus 2. Let me give this minus a little better. Alright. Now what do you think is the total number of elements present in the non-boundary, total number of non-boundary elements? Same thing, m minus 2 cross n minus 2. Here, the total number of elements in the non-boundary matrix is 4. And here, the total number of non-boundary elements is 9. So, the same formula yet again. Moreover, the non-boundary elements of a square matrix always begins at 1, 1. The index of the first element of a non-boundary matrix is always 1, 1. If you see, notice this particular element. Let's use a different color. Let's use this. No, not this. How about this? No, even this is not good. I'm not getting the correct colors. Okay, this one. So notice this. Even this is not contrasting. Come on. Okay, so this particular element. So this particular element has an index of 1, 1. So is this. This element has an index of 1, 1. This index is the index of the first element of the non-boundary matrix. Moreover, what is the index of the last element of the non-boundary matrix? You see, that's 2, 2, and here that's 3, 3, or in general, that's m minus 2, m minus 2. Alright, I hope all these observations are clearer to you. Moving on. Now, the next step was to find the sum of the diagonal elements. Before we can do that, we need to identify what are the indexes of the left diagonal and the right diagonal elements. Okay, so let's start with the row numbers. So when my row number is 0, what is the index of my left diagonal element, which is indicated by white circles? That's 0, 0. I'll come to right diagonal later. And when the row was 1, the index was 1, 1. When the row is 2, the index is 2, 2. So when the index is 3, row is 3, the index is 3, 3. You notice the pattern? See, for 0, the left diagonal index is 0, 0. For 1, the left diagonal element's index is 1, 1. For 2, that's 2, 2. So, in general, for I, what do you think the left diagonal element index should be? Pause this video for a second and think. I hope you gave a thought to it, and the correct answer is I, I. Alright, now let's move on to the right diagonal index for the time being. Alright, so when the row number is 0, then let me get rid of these arrows now. So when the row number is 0, the index of the right diagonal element is 0, 3. Now, for row 1, the index is 1, 2. For 2, it's where is it? Here. It's 2, 1. For row 3, it's 3, 0. Now, if you notice carefully, you're going to see that the row number is same as the row number. Of course, it's going to be the same, right? So, in general, for row I, the first index would obviously be I. But we are concerned about the second index, the column number. Now, can you figure out this value from the variables m and I? You can formulate a formula using these two variables and some constant so as to get this value, these values. So pause this video for a second and think, what should be the formula that would give us the column number for the ith row of the right diagonal element index? Pause this video and think. So I hope you did. And the correct answer is m minus I minus 1. So let's test that. So the value of m is 4, and the row number is 0, and minus 1. So we get 3. Let's try for row 1. So the size, so the value of m is 4, minus 1, and that gives us 2. 4 minus 2 minus 1, that gives us 1. 4 minus 3 minus 1, that gives us 0. Therefore, the correct answer is m minus I minus 1. I hope all of you have got this till here. I hope all of you are with me on this problem. I know the explanation may look a bit tricky, but if you watch it a couple of times, it will be clearer for you. Okay? Now, let's move on to the actual algorithm for this problem. Now, one thing that I mentioned was that we need to check whether the value of n lies between 3 and 10, whether it is greater than 3 or less than 10. That's the issue that we're going to address in our algorithm first. Okay, so let's start with step 1. As we know, the first step is always start. The second step, we take m as input from the user. Size in m. Now we need to check if m lies between the specified values. So if m is greater than 3 and m is less than 10, go to the next step, proceed, right? Go to step 4, else, go to step, and we will provide this later. Now let me see, are there any erroneous examples? Well, yeah, there is. The matrix size is out of range. So this is what we have to print if the matrix size is not valid. All right, so we'll fill this up later. Okay, so step 4. So as we've got the dimension of our matrix, we first need to create a 2D array. So create a 2D array named, let's name it matrix. Having size, having dimensions m cross n. Step 5, take input in matrix. We take input in our matrix. Step 6. Now we need to create a copy of this matrix because we have been asked to display the original matrix after every operation has been done. So we copy matrix into original. And this matrix will not be affected. The original matrix will not be affected. Okay. Change to a different color. Step 7. Our first job was to sort the non-diagonal elements. So for that, we need to copy the non-diagonal element, not non-diagonal elements, non-boundary elements from the matrix into a 1D array. So create a 1D array of size, and we know how many non-boundary elements there are. m minus 2 cross m minus 2, Step 8, copy non-boundary elements from matrix into let me name this 1D array. Let's call it temp into temp. Step 9, sort the 1D array. Step 10, copy elements from temp into matrix, replacing existing non-boundary elements. You see, the algorithm that I specify here does not mention how we are going to achieve that. It just says that we need to do this. This is what the purpose of an algorithm is, to mention the plan. The implementation is reserved for the code. From temp into matrix by displacing the existing non-boundary elements. Now that that's done, we need to find the sum of the diagonal elements. Now here, we need to be a little explicit. How so? We'll have two variables, sum left diag equals 0, comma, sum right diag equals 0. And we also would require step 12, two variables I and j, and I would start from 0 and j would start from, and we wouldn't require j actually. So what are we going to do? Oh, sorry. So we are going to generate numbers from 0 to m minus 1. And for each of the row, we are going to add elements belonging to this and this indexes, because these are my diagonal elements. Simple. In fact, I wouldn't require some right diag as well. I just need to add all the diagonal elements. So a single variable is enough. Some diag. Let's copy this too. Yeah, that's it. Now we are going to need a loop. Step 11, no, step 13. So what are we going to add in sum diag? Sum diag equal to sum diag plus matrix. And index would be I plus matrix I n minus I minus 1. That's it. And we're going to check step 14. If I is less than m, go to step, we need to increment I first. I forgot the increment part. This is the reason why I always tell to write algorithms in pencil first. I equal to I plus 1. Step 15. If I is less than m, go to step 13. Else go to step 16. Okay. Now, now that we are all done, now we need to display all the matrices, right? So display original, the original matrix. Step 17, display matrix, which is our rearranged matrix. Step 18, we need to show the diagonal elements, right? I'm just going to write display diagonal elements. I'm not going to write the code here. The code is for the implementation. Display diagonal elements. And then finally, we need to display the sum. Step 19. Display sum diagonal. Comma, go to step. Now, why am I doing this? You see, in the very first step, or in step 3, we needed to confirm whether m is greater than 3 and is less than 10. So if it is not, then we need to go to some step, right? So the step that we are going to go to is step 20. And there we are going to display the error message. Okay, so in step 20, so what was the error message that we were asked to display? The matrix is out of range. Display, it means a different color. The matrix is out of range. And finally, in step 21, we end. So we write stop. After displaying this, it's going to go to step 21. It's going to stop. And that's it. That's our algorithm. I know it's quite big, and the explanations, you haven't probably understood the explanation I did in the previous slides. Watch this video a couple of times. I hope that will be clear. Okay? So see you in the next one. It was a long one. Okay? Bye for now.